Dear students, welcome to Easy BTech, your guide for BTech and beyond. This channel is very helpful to you to understand BTech subjects very easily. And in this session, we are going to discuss orthogonal signal space. Very important topic, orthogonal signal space. Let's start our session, orthogonal signal space. So in the previous session, we have seen, in the previous class, we have seen what is orthogonal signals. Orthogonal signals. How can we say the two signals are orthogonal signals? That we have covered. Just I will repeat once again. For example, if you take two real signals, x1 of t, x2 of t, they are the two real signals. And over the time interval t1 to t2, the time interval is time instants t1 to t2. So if you want to check they are orthogonal or not, how to check? The integral product over time instants t1 to t2 x1 of t into x2 of t. This integral product, if you get 0, this integral product is 0, then what is the clarity? The two given signals x1 of t and x2 of t are orthogonal functions or orthogonal signals over the interval t1 to t2. This is the clarity. Okay. So this we have covered, and again we have seen the formula C12. This indicates, as we discussed in vectors, the value of C12 indicates how much similar these two signals are. The similarity between two signals, amount of similar or similarity between x1 of t and x2 of t. Similarity between these two, x1 of t and x2 of t, over the limits t1 to t2 only. Here time instants t1 to t2. Not for the total time we are checking the similarity, only particular time interval t1 to t2. So that is a C12, and we have formula for C12. We derived it. What is the formula for C12? Integral t1 to t2 x1 of t into x2 of t dt divided by this total divided by again integral t1 to t2 integral t1 to t2 x2 square of t dt, x2 square of t dt. So this is a way of doing C12, way of measuring similarity between two signals, that is C12. This is the formula we use. Today's session is the same continuation of this topic, orthogonal signal space. Today's topic, orthogonal signal space, very very important topic. Orthogonal signal space. Orthogonal signal space. So what is this orthogonal signal space? We discuss now. For example, consider a signal, continuous time signal x of t. This is the signal x of t. Now I am taking set of or group of n number of small n, maybe 10, maybe 20, maybe 30, n number of mutually n number of mutually orthogonal mutually orthogonal functions or signals. So we are taking set of orthogonal functions, mutually orthogonal functions, n number of mutually orthogonal functions or signals over the interval t1 to t2, over the interval t1 to t2, over the interval t1 to t2, t1 to t2. Now this is the second point. First we have taken an arbitrary signal x of t. Now I am taking set of n mutually orthogonal functions over the interval t1 to t2. So this set I am writing as like the set of mutually orthogonal functions. I am writing like g1 of t, g2 of t. This is the set, mutually orthogonal set. g3 of t and so on up to n number g r of t and so on g n of t. So this is the set n number of mutually orthogonal functions. What is mean by mutually orthogonal functions? What is the condition? Just now we have seen what is the meaning of mutually orthogonal functions over the interval t1 to t2, that is integration t1 to t2 gi of t into gj of t dt is equal to must be 0. Gi of t into gj of t dt is equal to 0. Here I and j not equal. I and j not equal. For example, we can say like this. For example, you take I is equal to 1, j is equal to 2. How to write this integral now? I is 1, j is 2. So g1 of t, sorry, here g2 of t dt. This product is 0. So that is the meaning, right? For example, equal, I and j are equal. So what happens? If I and j, they are equal. If I is equal to j, what happened to integral? Then integral t1 to t2. So you can take I is equal to j or j is equal to I. For example, I am taking I is equal to j. So gj square of t dt. Take this value as kj. This is the integration of gj square, right or not? Gj square and integration of gj square. This will be something like kj, some value or something kj. Okay. So this we are taking first. We have taken x of t, an arbitrary function or arbitrary signal, and we are taking n number of mutually orthogonal functions. N number of mutually orthogonal functions. So orthogonal functions means, so first I written n number of functions, right? Then mutually orthogonal means this is the condition. Gj of t or gi of t dt integration will become 0. Like I and j must be not equal. If I is j, it will become gj square of t. The value we are taking as kj. The value we are taking as kg. Now, what I am going to do, I am going to write x of t using this n number of mutually orthogonal functions. I am going to approximate. We are going to approximate x of t, arbitrary signal, any arbitrary signal, x of t, using all these mutually orthogonal functions, g1, g2, g3, and so on, gn. Right? So that we are doing now. Let's write that x of t is equal to x of t is equal to the first function c1 into g1 of t plus c2 into g2 of t plus c3 g3 of t and so on and so on, cr gr of t plus and so on cn gn of t, cn gn of t. So all the orthogonal, mutually orthogonal functions we have taken because we want to write x of t using all orthogonal functions. So after writing all these, we can take error xe of t. We can take error xe of t. This is the error signal, right? Now, instead of writing this total plus plus plus, we can use summation in mathematics. Summation we can write like I is equal to 1 to, it is started from 1 and ending with n. Therefore, 1 to n, 1 to n, ci gi of t, ci g of t plus the error function or error signal is same, xe of t is same. This total is equal to x of t. So using summation we can write. By this step we can write the error signal xe of t is equal to x of t minus summation I is equal to 1 to n, I is equal to 1 to n ci gi of t, ci gi of t. This is the error function or error signal. So our aim is what? We want to know how much is C1, these coefficients or constants. What is the C1 value? What is the C2 value? What is the C3? What is the CR? And what is the CN with minimum error? With minimum error. We want all these coefficients with minimum error. So that is a step. So I'm going to find Cj. If I is equal to j, it will become Cj. So I'm going to find Cj with minimum error. With minimum error. If I is equal to j, suppose I is equal to 1, C1 it will be. I is equal to C2, I equal to 3, C3 we can get. I equal to 4, C4 we can get. So I is equal to j, Cj I'm going to calculate. So that Cj must be with the minimum error. Minimum error. So we have mean square error. We know that mean square error. What is the mean square error? MSE in short form. It is MSE. It is indicated as epsilon. So epsilon is equal to 1 by T2 minus T1, 1 by T2 minus T1 integral T1 to T2 xe square of t dt. This is the mean square error, right? So we have to minimize this mean square error. That is equal to minimum error. We are going to minimize the mean square error means that will be meaning minimum error. In this process, we can get the Cj when you are going to minimize the mean square error. In that process, we get the value of Cj or formula of Cj. That is the way we are going to see next. So here, the error function we know, x of t minus summation. So I am taking as it is in the place of xe. So 1 by t2 minus t1 integral t1 to t2 integral t1 to t2. What is xe here? X of t minus summation I is 1 to n ci gi of t, ci gi of t. This is a xe. Whole square is as it is. So we have square dt. Now it is like a minus b whole square, right? So we go for expansion of this a minus b whole square. So let's see that expansion. This is totally epsilon or mean square error. Now the epsilon is equal to, after expansion, a minus b whole square, epsilon is equal to 1 by t2 minus t1 1 by t2 minus t1 integral t1 to t2 integral t1 to t2. So first term a square, that is x of square t. Second term b square, so plus I is equal to 1 to n b means ci square gi square of t. So a square b square minus 2ab, so 2 times summation I is equal to 1 to n, here a and b, so ci gi of t into x of t. So just we have opened a minus b whole square dt. This is the mean square error. So we have to minimize it. We have to minimize it, right? And we have to get when I is equal to j, we have to do the formula of Cj. So to get this Cj formula, we have to minimize epsilon or mean square error. So that is done doing this. So perform d by dCj means differentiation of this epsilon with respect to Cj, because I want to get formula for Cj, right? So d epsilon by dCj and equate to 0. In this process, we get the Cj formula. Let's do it now, which is equal to here 1 by t2 minus t1. If you send right side, it will become 0. So I'm not writing that. So d by dCj of d by dCj of the first term integral t1 to t2 x square of t dt. Next, the second one plus here we are doing Cj formula whenever I is equal to j. So that is why no need to take summation here. We are going to do Cj when I is equal to j. So here now again integral t1 to t2 integration is as usual. I am writing c1 square. So I is equal to j. That is why cj square and gj square dt. This is the second one, second integral. And the third one minus again integral we have t1 to t2. So this is 2 I can write out the number I can write outside the integral 2. Here I is equal to j, that is why cj gj of t x of t dt. This total is equal to 0. So let's see the differentiation of each term. The first term, what happened to, what is the differentiation of first term? So the first term, this one is a constant, integral t1 to t2 x square of t dt. It will be constant. So it is like constant, you may get constant. This constant again differentiation with respect to Cj. So it will be 0. Plus the second term, here we have Cj square is there. We can write outside the integral because integration is with respect to t. So Cj square and the differentiation of Cj square, it will become 2Cj. 2Cj and integration is as usual t1 to t2 gj square of t dt, right? Next one, third one. Here integration of here Cj we can write that Cj outside because integration is with respect to t. Okay, integration is with respect to t. Now this Cj we can write outside. So differentiation of Cj with respect to Cj with respect to Cj 1. So 1 into the total term, that is 2 into integral t1 to t2 integral t1 to t2 gj of t into x of t dt is equal to 0. So next thing, mathematical solution. What is the mathematical way of doing is you send this minus term right side, it will become plus, and we can cancel number 2 both sides. After that, we get like Cj and integral t1 to t2, integral t1 to t2 gj square of t, gj square of t dt is equal to, right side we get integral t1 to t2, integral t1 to t2, we can write like this x of t into gj of t, x of t into gj of t dt. So by this we can get the formula of Cj. So what will be the formula of Cj? Now Cj will become, so numerator integral t1 to t2 x of t into x of t into gj of t dt divided by whole divided by integral t1 to t2, integral t1 to t2 gj square of t dt. So this is a formula of Cj. So we have written approximation of x of t using n mutual orthogonal functions. How we written c1 into g1, c2 into g2, c3 into g3, right? And so on. So these are constants or coefficients c1, c2, c3. Suppose if you want to find what is c1, how to get what is c2, how to get what is c3 using the formula Cj. So if you take j is equal to 1, we get the formula of c1. How to do c1 value? J is 1. So integral t1 to t2 x of t into g g1 of t, here j is 1 dt divided by integral t1 to t2 t1 to t2 x of t, not x of t, g, here j is 1, so g1 square, g1 square of t dt, that's all. So this is a way of finding all the coefficients c1, c2, c3 and so on, right? So what is c1 value indicates, for example, if you got c1 is equal to zero point 0.1 in terms of percentage 10. So this g1 function is 10% similar to x of t. How much similar? That will be decided by c1 value. Okay, right? So next thing, we have taken this denominator already at the starting, integral t1 to t2 g j square of t dt. So we taken as kj, some value kj, that I am going to write dt is kj. So then Cj formula the same as it is t1 to t2 x of t into g j of t by kj, right? So this is a orthogonal signal space, orthogonal signal space. Okay, so we can stop here now. We have next session. Okay, in the next session we discuss some more topics related to orthogonality. So very important topic, orthogonality. So please watch videos, subscribe, share the channel. Thank you students, thank you all.